Okay, hello everyone. So first, thank you all for coming today, and especially for staying up to this time. I know it's a complicated hour, just one more session after this one. We're all thinking about the beers afterwards, but just try not to fall asleep, please. Um, okay, so, well, you obviously chose the session. If anyone at the end has any type of doubt to how to apply this technology or whatever, just stay at the end, or I'll put up my QR for LinkedIn so you can connect and message me afterwards. We're going to talk about Azure synchronous messaging services. Okay, so there are mainly three. We'll talk about each of them during the session. And I've tried to give it a touch of cooking because I really like to cook. It hasn't been that easy, so just think or imagine that I was wearing like a chef's cap or something. My name is Sofía. I am a software architect at Prodware. I am from a little town in the northwest of Spain called Coruña, but I live in Madrid. I went there, studied biomedical engineering, and ended up here. I still don't know how. And I specialize in Power Platform and Azure solutions. And, well, that's my professional picture, but I'm also a foodie, and I love to travel just to try new food. And I'm also crazy about sports. So I'm kind of like this weird mix, just so you guys can try to understand me a little better. So what we're going to see today, in the most recipes or cooking processes, the first thing that we have to do is the mise en place. Okay, that is basically putting up all ordered in the table. And then with those ingredients, we're going to define the basic recipe of event-driven systems. Then we'll see a few theoretical cases and one demo of a practical case that mixes the three of them. Then we'll mention a few of the architecture patterns that Microsoft suggests for specific systems and a few best practices about the event-driven architecture. All right? So welcome all to Hell's Kitchen. As I was saying, we start with the mise en place. Okay, we put everything on the table. So what are integrations and all this? So basically, every system nowadays talks to a different system. Every app talks to another app. Your CRM might be connected to the ERP, that might be connected to the HR system, that might be trying to send birthday messages through Teams. So they are all connected. But if the timing is off, or if one cook burns the sauce, the whole system can fall apart. So what are integrations? They are the connections between independent systems that allow data to move, transform, and trigger actions across a whole business flow, making it all behave as a single ecosystem. So basically, the bridges or the glue between your applications. Okay, so if I create a contact in my CRM, then it will magically appear in the marketing tool for me to send a campaign to it, or magically appear then also in a Power BI. Why? Because they're all connected. So those are the integrations. So it's basically the digital version of running a professional kitchen. There are many teams, each in charge of a different side of the plate, okay? And they all try to work together to serve a perfect plate, a perfect customer experience. What's the problem? When you have little things, or even big things, all over the place, and you try to connect everything, well, every single one of them can fail, can break. Okay, so in the real world, systems don't truly behave like a good team player. Okay, so APIs fall, network latency spikes, then you have rate limits that hit, and one small delay can provoke a cascade through the multiple systems and break the whole thing. So can you imagine in a professional kitchen, if the cook drops the sauce on the ground? We've all seen those movie scenes where just one slips and everything goes flying in the air, everything breaks, and then the music just screams drama in the back. Okay, so that's basically what's called the integration chaos. Okay, when systems are so tightly coupled that one slow response can turn into a full system break. Okay, so basically we have the failure of the integration chaos. That means that a single retry can make everything explode, okay? But integrations do not have to be chaotic. They do not have to behave wrong. We can build systems that breathe, that react independently, where messages wait patiently, okay? Where errors and mistakes and failures can be handled really smoothly and nice, okay? And that's basically it. The integration is sending the data, but also in the right time, in the right way, and even when one of the pieces of the puzzle drops and collides, okay? So that's when asynchronous messages come in. So basically, they're the secret ingredient for a smooth cooking process, okay? They let your systems communicate calmly, resiliently, and even when everything else is on fire. So today we're going to talk about the three main Azure messaging systems. There are Service Bus, Event Grid, and Event Hubs. We're going to see the difference because each one has a different flavor, but when we mix them together and we can make a very nice combination, we make scalable, flexible systems even when things break. So that would be Azure, Grid, and Hub. Okay, so the ingredients for our recipes are not just these three tools, okay? They are our tools. We are going to talk about the single things that need to be configured within them. So the first things, we need to differentiate between the two types of messages. That's the main classification. A command is an instruction. It orders you. You have to do this, okay? You use it when you need a guaranteed delivery and the confirmation that the task has been accomplished or at least done. It's like when the waiter comes up to the kitchen and say, you need to process this order, we need a spaghetti, okay? So the cook must do the spaghetti. However, an event, okay, it's more of like a decouple kind of message. So there are no demands, there are no expectations of anything to happen. It's simply a notification that something has changed or something has occurred. It's more like when you ask Amazon and Amazon just emails you and tells you, okay, your order was shipped. Amazon is not expecting you to do anything, just you needed to be notified of that, okay? And this difference is key to later choose which of the systems we need to, the tools we need for our system. Okay, because commands are more, okay, they flow through systems that need more reliable communication, and they need acknowledgement of the receival. But then events are more of like a fire and forget, or the goal is distribution of the information and the reaction, but not the control. Then we also have three different types of actors. We have the producers, the brokers, and the consumers. So basically, the producer is the system that is going to generate the message or the communication. The broker is the middleman, okay? It's like the post office. It just makes sure that it receives a package, and then it is delivered to the destination point, okay? And then the consumer it's also the listener. So it's the one who is going to react to whatever is sent to them, or they're even going to pull it, okay? So when they process it, they can do whatever, but at their own rhythm. So the magic here is that the broker allows us to leave the producer and the consumer without communication. They do not need to know each other, okay? So the broker in here just makes sure that they can work at their own pace. So even if the producer is just sending messages continuously, if the consumer is quite slow, it's all right. It's going to wait for them, okay? So why would we want to use a broker? Okay, so by decoupling, by making them consumer and producer independent, that they don't know each other, it brings order to the chaos, okay? So it decouples them and allows them to work independently. And that allows the temporal independence. That means that the broker can handle those messages in queues or in topics or whatever during a certain amount of time so that the consumer does not need to speed up. It can go at its own pace. Okay? It allows load leveling, that means that it buffers the traffic spikes so that system doesn't collapse under load. Okay, it improves resiliency, but making sure that the messages are delivered. And it gives observability and control and the ability to replay messages, okay, track the delivery, detect duplicates, and a concept that we'll see later, that it's the dead letter failures, control them, okay? So these are the three systems, okay? So the service bus would be, as we were saying, as the post office clerk, okay? It's just reliable, transactional, it's just always there. Okay, the event grade is more of like a messenger pigeon. It's just very small, very quick, but it can handle very light loads, okay? And then it will tell the subscriber whatever. And the event hub is a fire hose of data. It's like all you can have, okay? Just full thing, the whole thing. And it's optimized for streaming millions of events per second, okay? So the load there is very large. So when speaking about the messages type, when we work with commands, we want to go with Azure Service Bus. But then when we're talking about events, depending on the payload, the volumetry, etc., we are going to decide between Event Grid or Event Hub. So there are two communication models that would be push or pull. Pull meaning that the consumer needs to grab whatever is on your queue, on your topic, on your box. Okay, they need to ask for it. Or push is just okay, whoever's listening, there he goes. All right. So for Azure Service Bus and Event Hub, we go with the pull. Okay, that the consumer must read or must obtain the message. But when talking about Event Grid, it's this system that pushes into the subscription subscriptors. Sorry about that. The message. So that makes Azure Service Bus perfect for more reliable communication, but it also has many advanced properties and capabilities like FIFO, that means the order first in, first out. It keeps the order of the messages. Whatever comes in is going to come out first. Okay, it helps with the duplicate detection and the dead letter queuing. That it's basically that after many, many failures that you can define the number, it will not lose the message. It would make sure that it stays somewhere where you can check it later manually. The event grid, as we were saying, it's for lightweight loads. Okay, it's very fast, very cheap, but it's also prepared for a little charge. And then the Event Hub is more of like high throughput partitions that we can go with telemetry, with logs, that everything you can imagine that might need millions of data transactions per second. That would be the Event Hub. So if you see a QR down on the bottom, that's basically the resource where I got the information from, just in case you guys need to check it out. So how do we choose between these three? Okay, so there are a few questions that we can ask ourselves, starting by, is it an event or a command? So the type of message is going to tell us first which side we want to choose. Then we can go with the volume. If we need massive transactions and we are talking about events, we are going to go with the Event Hub. But if we are talking about very light volumetry or lightweight, we can go with Grid. Okay. If we want serviceless and reactive, a type of fire and forget message, that would be Event Grid. Okay. If we want to replay the messages, the situations, the analytics, what happened last night with my system, that would be telemetry or logs. We would go with Hub. Okay. That was this one. But remember that you do not need to choose just one. Okay, by combining them all, you might get the perfect system, because during in the design of a system, you have different parts, okay, and each one has a role. So depending on the role, you might need to combine them all to make the system truly reliable. So this slide is kind of a slight repeat of the other one, but not truly. So this is the reasoning flow to design your event-driven architecture. So first, you need to define what the message represents. That means not just if it's an event or a command, but also the payload, the size of the payload, what needs to be sent from one system to another. Then, of course, we need to separate and make independent the systems. And to do that, we also need to choose a pattern that will make our system meet the requirements. That means the retry policy. That means the load balancing between the different subscribers, if it needs to be separated by percentage or by metadata or whatever. Okay, we need to define how we want them to communicate those systems. So with that in mind, we can select the broker or the service that supports that guarantees. Okay. Then finally, we need to implement idempotent consumers. That means assume that in an asynchronous messaging system, messages are going to replicate and duplicate because we're going to keep retrying messages, or even because the sender, the producer, is going to send many messages equal by accident, and we need to be prepared for them. So we need to prepare the duplication policies, okay, to handle those repeated messages without it affecting the end system. And well, we need to, of course, design for and prepare for failure, because we all know that Murphy's law is just inevitable. Okay, so the worst will happen eventually, and we need to prepare for that. Okay, so now we're going to see a few theoretical cases. First service bus, then grid, then hub. Okay, and then we'll jump into the demo. We're going to work with a single basis scenario that it would be a company. Okay, it has a Dynamics 365 for Sales as CRM, and it's connected to an old ERP system that only accepts batch updates. Okay, and it goes offline quite frequently because of maintenance reasons. And well, in this case, we need to process the financial data, and we need to move financial data from the CRM to the ERP system, and that's critical. We cannot allow to lose that information. Okay, so in this case, the issue here would be that the synchronous API calls are not enough. They're not sufficient because the ERP is going to be down many times. So we would need to prepare, of course, an asynchronous messaging pattern. Okay, and in this case, since it is we need to guarantee the deliverability of the information between one system and the other, because, as we were saying, financial data is critical. So what we would do would be connect our CRM to a service bus queue that can be done through plugins, that can be done through Power Automate, whatever integration you might think about. It just sends it to the service bus queue, where it will be waiting until a separate Azure function or logic app, okay, just listens to it and just gets the message and processes it. Okay, then that would be the processing, would be the sending it to the ERP once it's available. In the case that the Azure function or the logic app execution fails, then it will go back to the queue and wait until the next retry to be processed again. Okay, and then the dead letter queue, as we were saying earlier, it stores the unprocessed messages for manual review afterwards. That means that no data is lost. Okay, it will always be there until someone decides to process it and remove it from the queue. We have another case, which would be for an event grid. Then, in this case, the same company through the same CRM, they want to notify the third-party marketing tool that a new contact has been, a new lead has been converted into contact, and they need to start a marketing campaign automation on them. And the external system, okay, needs to create also that contact. They need to be notified of that creation and replicate the contact in near real time to send that marketing automation. Would be just when we enroll in a website, or we need to get the email quick, okay? So the marketing tool API has a limited resources and fails to respond frequently, so we cannot be waiting for that response. And if they were to make a webhook to our side, it will become crazy because it will completely saturate and overload the system and the connections. And of course, it would be inefficient. So the solution here would be to use an event grid. So the CRM publishes into the event grid the contact information that has been created, And then the marketing system just detects that topic creation, and then if it fails, then the grid retries the delivery continuously. It goes calling them like, hey, it's here, it's here, it's here, for whenever they're ready to listen. Okay, and then the third one, just for the Event Hub, it's more like a buffet. Okay, so it serves a crowd of data consumers at scale with a whole set of data. So the company integrates with IoT devices installed at the customer site. That can be any type of situation on any type of client. It can be gardening. It can be industry, whatever you think about. Okay, so the devices will send real-time usage and performance information to the whichever platform we choose. Okay, and that information must be stored so that it can be used for both Power BI and data analytics and for customer service incident reports, alerts, etc. Okay, so here we have the issue that the telemetry is continuously showing. Okay, and it arrives at a high velocity and a high volume, and then neither CRM or Power Automate or any extension of the suite that they have prepared is ready or is able to handle that data stream. Okay, so we need a scalable ingestion pattern, and that's where Event Hub comes in. It is great because it allows that massive throughput. It easily integrates with data platforms, not just Power BI, but also Synapse, also Fabric, whatever you think about. Okay, and it allows multiple analytic processes in parallel. Okay, with consumer groups. That there's a slight issue here that is not always mentioned, but it's not critical in these cases. That is, there's not 100% guarantee that the whole data set is going to be processed. Okay, so most of it, yes, but messages might get lost. So there's no guarantee like we would have in Service Bus. Okay. Also, it is way more complex to configure compared to the event grid. Okay, so now we have a fourth case that, as we mentioned, cooking the perfect dish might be combining all the perfect ingredients. Okay, so in this case here, imagine that this company with the CRM is merging into a larger one, so they need to report their orders to an external ERP until they all merge through the same system. They need to report them in near real time without risking duplicates or saturating the ERP. Okay, because that's like a massive company buying procedure that a huge one does, and they acquire like 7 different companies, and they all need to simultaneously change their processes and start connecting to the new ERP. So it might get saturated and overloaded if all of them send continuously. So in this case, what we need to do is through Power Automate export the created orders from Database and send into an event grid topic that handles the lightweight payload and simply just sends it out. Okay, so it will be received by a service bus that will have it in queue until the ERP is fully ready to accept it. Okay, and then for the demo purposes, I switched the ERP for like storage container. Okay, so it would kind of look like this, basically. So we get a new order. Then through Power Automate, we send an event grid topic new subscription. Then the logic app is going to jump and connect the event grid to the service bus, which in its turn is going to call to the Azure logic app, and it's going to record a new record in the storage container. Okay, so if we go real quick here, so I'm going to show you, I'm going to show you the first, a little bit of the components so that we can go over all the configuration. So first of all, we have this Power Automate that simply connects, and it's going to perform an event grid invocation through HTTPS. Okay, so we simply need to get the URL and the key, and we will define the body. In this case, as you see, I chose to create a huge body. it should have been maybe just one key, the unique identifier of the record, because then the later processing systems might actually access the whole data if I need it. But well, then this one is going to call an event grid. So when we create an event grid service in Azure, you're not going to just create event grid the same way you create a service bus or you create a function app. Okay? You're going to create a topic, for instance, that can be custom or not. And that's going to allow you to make then the subscriptions based on the subject. Okay, so that's basically you create a topic. It's like creating the queue or the column where you insert the information. And it will have subscriptions. If I wanted to create a subscription, I would simply need to say which is the event type that would be in the subject. And that's basically what I can later use to decide which of the consumer is going to get the information. And then in the endpoint type, I have different options. Here, we are not going to see Azure Logic Apps because it's going to invoke it behind the scenes as an HTTPS. So it's basically going to be the same as a webhook. Okay, so if you want to connect your Azure Logic App to the event grid subscription, then you're going to have to do it through the Logic app. Okay, it's one of the tiles that we're going to see. So basically, for now, we have the order that we create. Then it triggers Power Automate that will send the information to the event grid that is going to be listened by an Azure Logic app. Okay, so let's see if it works like this. This is connected to our resource. Okay, and I am telling here which is the event type that I'm sending. Okay, which is it must be the same as what I have sent here. Otherwise, it is not going to appear through this subscription. Okay. Then, well, we can make a few settings with the retry policy and tracking here. Careful, the tracking here is quite tricky itself. You can only use a certain boxes of the flow that are being actually connected to the box that you are going to add the tracking to. So if I want to add tracking here to the send message, I cannot use the parse JSON or the get role by ID. Okay, I need to only use the ones that are directly connected to the box. So it's quite not what we would need here. Well, then we just get the JSON, we parse it, we get the information of the row ID, and then we compose the message that is going to go to the service bus. Okay, then this way we connect to the service bus. We have here a service bus with simply max delivery count of 10 times. After 10 times, that's considered a full failure. Then we are going to tell that the message can exist within the queues for 14 days. And here we still don't have dead letter messages, but we could. And then, so here we have connected, okay, our Azure Logic app to the sending message in the Azure Service Bus service. Okay, so it's quite interesting that when we review the executions of this Azure Logic app, although I am here in the compose, I am composing this beautiful JSON message. Once I click it here and I add it into the context, it's going to transform automatically to base 64. Okay, so the first thing that we need to do later when we try to access that message is also translate it again. So it should, when we execute this flow, just travel through the active messages, and it will end up here in this other Azure Logic app. So from the queue, we're going to connect it to the message received here. We're going to parse it first, all the base 64, then give it a JSON format, and then it's going to go into the blob storage that we connected to create a single record. Okay, so I hope it doesn't fail now. So we can go here with the Azure Dev Summit pizza order. It would be, I don't know, 1,050. 1,500, sorry. So it generates the order with the code, the title, and the total amount. And then when we go to our Power Automate runs, it should eventually be triggered. OK. So we add the order, and it simply fires to the event grid so that it is notified. Then we can see here in the subscription that we are going to have in now when it comes in. OK, it's not. Let me see real quick. OK, so it jumped here. I just cannot see it in the logs of the event subscription. OK, but I can see here. OK, so it has invoked it has gone through the grid, and it has executed our Azure Logic app. So it has composed a message. As I was saying here, the output here is quite pretty, but then when I go to the send message and I can check the content, if it's at some point available here, the content is now base 64. It probably is not in the queue anymore. It might have gone already to the next one. So when we can check the run history here, then the message has been received in the queue. And then one interesting parameter here that we have, I'll show you right away. So the content is received in the base 64. We then parse it to our JSON format. Then we send it to the create blob. And here we should have it. OK. So when we want to try and check it out, so it's going to be the Azure Dev Summit pizza order for a total amount of 1,500, and the unique identifier that we have here. OK, that would be the key, the correlation ID. That's what we're going to use later for monitoring. But what I wanted to show you real quick, it's here when we receive the message, OK, we can tell it how often we want to check for items. OK, so in this case, we simply have an Azure Logic app that is going to check every minute if our queue has new items. The same way we can configure this check-in, this polling, as we were saying earlier. OK, we can also start configuring different settings that are quite interesting. Of course, the action timeout, but also the concurrency control, so that we only allowed it to process 5 at a time. Then so it would be this one, I think. So when we send the message here, in the settings, we can choose what asynchronous pattern we are selecting for that retry policy. So in this case, there's a default one, but we also have the exponential interval that allows us to make sure that when we send the messages, it's not always like every 3 seconds, I'm going to try again, I'm going to try again. But if it's failing, then give it a little more time to react. OK, so in this case, we need to use this ISO whatever rule type of lettering here. So PT is for the interval period. OK, then we get the seconds, we got hours, we got minutes, of course. OK, so here in this case, we got a minimum interval between 10 and 60. That's the most that it can wait to retry the send. Of course, I only put 3, but we could have selected many more. Okay, remember that one thing is that receiving in the service bus here, and the other one is sending from the service bus. So here I'm going to tell it how many times I'm going to try and send it to the service bus, and then in the service bus I can set the retry policy to sending outwards, not to receiving it. Okay, and that's basically the main flow that we were talking about earlier, but we also could have done it with Azure functions, okay, with code. The difference is, of course, the connections change. In this case, what we do is we have the Power Automate. We connect it to the grid. Then the grid has the trigger for this function that then is the one in charge to send, well, in this case, it's going to check for more information against the database. And then it's going to create the sender for my service bus message. It's going to send very little information and just send the message asynchronously. Then this message is going to fall into the queue at the Azure service bus. And we are going to have a second function that is triggered by that service bus message. So in this case, we have the connection. Careful here when you write it. The same way that we get environment variables for other information that we need to hide from here. In this case, we have to input between the double brackets the name of the variable that is configured in the Azure function, not directly like what would be your variable within here once we extract it from the environment variable. Okay? And well, this is basically a deserialize of the message, and then it's going to connect to the blob storage and create a new item there. Okay, basically same architecture, it just changes the way we do it. It's either low code or pro code. You all know, of course, that well, I'm not into that trend, but I know most companies now that work with Power Platform. I don't know how many of you have worked with Power Platform. Okay, not too many, but just a few. And most of you with Azure, I understand. Okay. So in Power Platform now, they're all trying to just simply go back to the no code. Okay, they're going not only just low code, but no code. You've probably heard about the generative pages now that they're popping up, and they are just simply trying to avoid human error. But we all know AI also makes a lot of mistakes. So in this case, why we would choose Azure Logic Apps instead of Azure Functions? Basically because the code can fail more easily than the no code and all infrastructure from Azure. But truly, I myself feel more comfortable with code. I assume that most of you guys do too. Okay, so just go for it. It works very nice, very smooth. You just need to be very careful with where you get the connection strings. And one thing that was the death of me first when I started working with this is the managed identity and RBAC privileges. Okay, so you need to continuously give all the applications that are accessing, well, the service bus, okay, and the storage and whatever. You always need to give it permission to access. It would be either as a sender or as a receiver or whatever. But with the event grid, it doesn't happen. You don't need any type of control there of who connects to it. Okay. Okay. Let's go back to the demo, to the slides real quick. Okay. So as we were saying, okay, I recorded the video just in case it failed. It happens quite more frequently than we would like. And well, it could have been with Azure Functions, as I just told you. And now we're going to see just three architecture patterns that are Microsoft-based. Okay, that's what they suggest we do. And then I'm going to talk to you like for a minute about a particular case that I had that broke my brains at the moment a few years ago. So first, we have this architecture pattern that basically is just the service bus is going to store the messages as they arrive, okay? And it's going to be the reliable queue for the synchronous communication. It's just going to be there. You know, you can trust that it's going to be there. Okay, then the event grid is going to detect when those messages arrive, and it's going to send a notification to the logic app that is going to then act on the queue. Okay, so basically this would be, I don't know when the logic app is going to be ready or not, but I know I do not want to be sending the messages and removing them from the queue. I just want them to stay in the queue until someone actually comes and processes them. So I'm going to use the event grid as a middleware between my service bus queue and the end system that it's going to then process it. Okay, so it's basically the service bus holds the data, the event grid notifies when it is there, and the logic app is going to take it, transform it, and serve it to the final system. So we have this other one that would be more of an example of a deleted contact. Then you need to send the confirmation email and notify other systems. I thought of it as a GDPR kind of process, that when a contact tells you, please stop communicating with me or just delete my contact, then it's going to go towards a grid that is going to send the information to different systems so that they are notified and they can take actions, or they can process the information in whichever way they want. But then I realized GDPR is kind of something you don't want to mess with. And maybe a fire and forget style of communication is not the best, but it would work just fine. So basically, you have the event grid that just receives the events of a research group events or an original producer system. And then with some subscription filters based on metadata, as we were saying earlier, we have that event type that we can add it in the Power Automate to define within the topic of the event grid where it might go later for the subscriptions. And then, depending on the information, it might go to different places, to the same place. We can filter the direction of the information flow. And then the logic app is going to react to that selected items, okay? And it's going to notify via emails for whatever. So in this case, the event grid is just a routing system for smart communication. Okay, and then we go to a little bit more complex one. This one would be for a mobile app that analyzes images in real time. So basically, in this case, what we have is whenever a user uploads an image into a blob storage, then that's going to trigger an event grid subscription that is itself going to notify to the Azure function that there's information ready there. So the Azure function would communicate with the computer, the Azure AI Vision Computer API, and they will extract the metadata and all the information about the image. Then it would send it to the data storage with the metadata, and the front end web, the mobile app, or whatever is going to consume it from the data storage unit, in this case the Cosmos DB, and it's going to show it in near real time. So basically, the image is uploaded, it is analyzed by AI, and then it's stored in the Cosmos DB so that it can be consulted through the web application or the mobile app. That could be something like a shopping catalog. Okay, when you are building your catalog, you just prepared your application, then you go through the store, you just take a couple of pictures and you upload them. Then the program does the rest, and then it's automatically, almost in near real time, available for the customers to be consulted out in the front end. So before we go to the best practices, I wanted to talk about this one case. I don't know if you guys have had this issue where the client doesn't really know what they want. No? So we had this project in Madrid, where the customer, we had a CRM system, and what they wanted to do was process all the the unpaid people, so the people that owed them money, they wanted to communicate with them. So their idea was with Dynamics 365 sales and marketing, they would mix it to make some automated campaigns and first send text messages to the customers and then let them trust that they would contact you. And if they didn't, then you start already calling them. But first you would send them a text messages like, hey, please contact me if there's an issue with your subscription or whatever. In this case, it was many years ago, and I was quite the junior developer at the moment. So what I did was just trust the tool, and I forgot to ask about the volume and the amount of messages that they had to send. So what I did was just, OK, I'm going to make a simple marketing automation campaign. I'm going to let the messages flow. And well, this company had different small companies within it. I mean, business units, so to speak, but truly different companies. So in my head, when I was testing it, I was testing with one small company with just 100 customers. Of course, that worked just so nice. So what happened when we went into production? It was 13 companies with many more people in it. So everything went down. So that's when we decided that we needed to implement asynchronous messaging. We chose Azure Service Bus. We connected it through code. So what we did was simply, through the marketing automation, we would create the messages and send them to the queue. And then the queue would send them to the SMS provider that would send the messages. First thing that we did was separate them in batches of a certain size. For instance, they would send the messages at 9, 10, and 11 in the morning. And their idea was to separate them in batches of similar to equal size because they wanted to not overload the call center. Because, of course, if you send a message saying, hey, please call me, we have an issue with your subscription, we all know maybe 10% of them called, but that 10% of 500 can be more than enough to saturate a small contact center. So in this case, we prepare those small batches, and then there are many features that I have not showed you, and I'm sure you might know that they exist, that allowed you to not only just wait for a certain time like we saw in the Azure Logic app, that when you connect it, you can tell it how long it might pass between each execution to ask to the Azure Service Bus where the information is, but also when you send it to the Azure Bus, you can indicate how long it must stay in the queue. With that, I mean that you can define the sending time. So what we did was prepare those batches and assign the sending time, okay, escalated so that it wouldn't overflow. It's not like the greatest architecture that we did, but still could have been worse, and it worked. So even when you guys think that you're building your system designed to fail or whatever, just truly think about one topic that most of us forget, is the load testing. Okay? It doesn't matter that it's asynchronous messaging. Please perform load testing. You can do it for free. You can do it paying. You can put it all in your ALM cycles. No problem. Just please do it to avoid crisis. And I talk out of experience on that one. So let's move on to the best practices. I feel now like an old grandma just speaking to you guys, like those times that happened to me. So we're going to see the common kitchen disasters and the good practices that can be applied. I promise that's the last one. Okay, I've seen some eyes closing. I don't judge you. Probably would have happened to me too. So we're going to see this real quick, the common issues that occur. okay, when preparing event-driven systems, and the good practices that might help solve them or avoid them. So there's this concept, there's the retry storms, that is the instant retries that flood the system. What that means is that when an API or an endpoint fails, okay, the clients often prepare the retry immediately. So it's going to enter in a kind of an infinite loop. It's going to provoke a load peak, okay, and it's probably going to cause the full system to collapse. So what we can do is delay the retry with growing intervals, as we would say. First, you wait 5 seconds. If it doesn't reply, then you wait 15. Then if it doesn't, then you wait 30, or something like that. Okay? And then that's the exponential backoff that is going to allow the smart retries. And that's allowed in the service bus in the event grid. Okay? Then what happens with poison messages? What are those? This is a bad request, basically. Okay, when the data that we received is wrong, it's going to continuously go back to the queue and start reprocessing and reprocessing and reprocessing. And it's always going to be a bad request because the data isn't changing between one and the next retry. So basically, it's going to, in the end, stop the queue because the progress in the queue, because it's going to continuously go back. So what we can do there is the dead letter queues, the DLQ, that is going to allow to move those unprocessable messages to a special location after the number of defined retries that we decide, so that they can be checked. The same that we've been talking throughout the session. Then we have the duplicate records that are the repeated processing creates chaos. That basically, I'm pretty sure that all of you have had an Amazon or maybe a whatever package that it's duplicated. I've actually asked IKEA for some bed sheets, and I got 3 packages, and I only paid 1. And of course, I did not return them. But these things happen to the best of us, okay? So what we need to be prepared for that. Okay, so how do we do that? So we create the idempotent consumers that we talked about earlier. So that is going to avoid the duplicate in the consumer. So that's going to check for the same ID or the correlation ID or the transaction key. And if it's already been processed, then it's not going to process it again. It's going to discard it, but not return a throw or not going to return a failure so that it goes back into the queue and is able to go again. Simply discard it, but already in the consumer side. Okay? And finally, the invisible errors. Okay, so no monitoring until the users complain. I'm sure most of us have been there too. So without an alert or a proper monitoring system, the failures can become catastrophic, not because they might be huge, but simply because we cannot find them. And then I don't know how many of you work directly in a final customer or a client itself. I'm a consultant. So when you're in the consultant side, having the customer continuously ask and call you and ask you, how is it going? Have you found the error? Or have you, okay, it's better to, I don't know, spend a couple more days during the development processes and charging the client a couple more hours just to create a full monitoring system that is going to really help you when things go wrong, because they will go wrong, okay? So through App Insights, through Azure Monitor, through the log analytics, all the systems will send logs into a single observability layer where we can create then different metrics and custom query language queries and even workbooks, like they call them now. And we will be able to see what's really happening behind the scenes and truly make it resilient at a long distance. And then, well, of course, the main key of the session would be expect failure, because it's going to happen. So just make sure that you design the systems that degrade gracefully, that can handle those mistakes, that can take a breath, okay, and not go screaming all around. because it's going to be there and it's going to happen. And there's actually another tool in Azure that it's called the Case Studio that helps you prepare for not when your part of the system fails, but when you have a full failure, like the network fails, like I don't know if you heard, I don't know if it affected Portugal, but just a few months ago we had a full outage in Spain for a whole day. So it's going to prepare your system for things like that. Well, maybe not 24 hours, but for a few hours of outage, okay? So monitor chaos, load testing, whatever you do, whichever tool you choose between the asynchronous messaging, you cannot just think about one single part, one single step of the process, okay? We need to shift left all the testing so that we can actually make these tools worth their value, okay? They're quite cheap. Well, not the Event Hub. But in general, I truly recommend the asynchronous patterns that Azure provides. And hopefully I did not bore you too much. I promised it would be not too long. So well thank you all for staying, and thank you all for coming. And even if it's not in the slides, thank you to all the sponsors that actually make it possible for us to be here today. So enjoy the rest of the day and the rest of the sessions.